move the. Okay, I asked you to do this and this, right? I asked you to do 5 and 6, right? I wrote down the equation. Correct? I wrote down the equation. Then I asked you to do question 5 and 6. Did you do? Okay, never mind. You write the equation first. Okay, okay, okay. So you write the equation first. So you count first. First. Let me teach you how to do. So, step one. So, this equation I give you, usually you won't be given the equation. Okay. So, calculate the mass and volume of chlorine gas. So, they want mass and volume. Required to have is 7 grams of iron. So, first step is to find the amount of moles of iron. So, mass over molar mass. How much is this? 0 point? Okay. So you're supposed to find chlorine. So 2 to 3. So if it's 2 to 3, then it's 0.1252. So chlorine will be 0.125 times 3 divided by 2. Ririn, you know why? No, no, you look at this. Did you get this? Yes. You got this part? Ah, okay. Okay. 0.1875 mole. Very good. So now the question wants mass and volume. So first we find mass. Zero point 0.1875 times 71. 13.3125. Okay, so that's the mass. And then after that, we find the volume. Uh, times 22.4. Huh? No, it's just times 22.4. 0.2. Sorry, what? Oh, 7 grams. No, this one is, sorry. This one is 71. 35.5 times 2 CL2. Did you multiply 31? 31? 875 times. That's really good. Get it? No? No, 35.5 is CL. Chlorine is CL2. Then the one at the back you count. The one in front you don't count. Okay? All right. Okay. Do this and then we will go to the next chapter first, okay? Because I want to do the next chapter. The next chapter is chapter 4 is the last chapter, right? Chapter 4 is the periodic table, that's the last one, right? Okay. Too bad. I can't help you. Go wash your face, huh? Go wash your face, wash your face. Okay, you finished your question already? No. You know what? You go wash your face, come back there and discuss. Yeah, okay. Okay. Okay, so first step, you calculate the moles of sodium. 0.46 over 23. How much you get? 0. Okay, so if this one is 0.02, you're looking for hydrogen. Same double or half. So 0.01 minus 22.4. You get 0.224. Correct. Is that what he said also? Yeah. Okay. Correct. Continue this chapter because this one is theory. So we'll do theory, then we'll go back to calculation so that you don't forget because it's connected to each other. All right, can okay. Okay. So now you get the hang of it already. So we're gonna learn in this chapter. We're gonna learn. Okay. This whole chapter, we're only gonna learn a few things. We're gonna learn group one, which is lithium, sodium, potassium, rubidium, cesium, francium. We're going to learn group 17, which is fluorine, chlorine, bromine, iodine, acetylene. We're going to learn group 18, helium, neon, argon, xenon, radon. And then we're going to learn transition metal, which is from here to here. This entire block of metals here, the middle part. We're not going to learn it individually. We're going to learn it like overall what they can do. Okay. And then finally, we're going to learn if it's across a period from here to here, how does it change? Okay, so this chapter is very, very easy. Now, what about hydrogen? Hydrogen is not in group one. Hydrogen is just there, but it's not in group one. Okay, okay. So let's start with group one. Group one is also known as alkali metal. So because the name is alkali metal, do you think it's a metal? Yeah. So it is a metal, but it's a special kind of metal. So these metals are special in terms of, let's see, a typical metal is iron. Iron is a typical metal. If I take a piece of iron nail, okay, and I put in water, okay, I put a piece of iron nail and I put in water, what's going to happen? Okay, iron will, you mean? Immediately when you put, now everybody answers that. You're not like, oh, I'm the dumbest person in the world. No, everybody says that. But they don't, it's a trick question. I put an iron nail inside water. What do you see immediately? I don't think it would just sink lah. Immediately it will just sink to the bottom, top, and then that's it. It will just stay there. It won't rust immediately. Eventually it will rust. Correct or not? Okay. So what does that mean? That means iron is high density. Okay, iron can obviously sink. It's high density. Iron is sonorous. There's a clunk clunk sound. That's called sonorous. Okay. Iron can be molded into an iron nail. That means when I have pure iron, I knock, I can make into a shape of iron nail. That's called malleable. Okay. Iron, if I go and polish, it's shiny. Can iron conduct electricity? Yes. Okay, so conduct electricity, malleable and shiny. All metals can do that. But if I take group 1 metal, a group 1 alkali metal like potassium, sodium, or whatever, and I put inside water, it's not going to go tong at the bottom. It's going to fizz psst, and it will. Sometimes it will explode. No, nobody is going to put
Someone actually toss some sodium, they just toss it into the oven gently. Yes,
How do you know that?
from my teacher's information.
Oh, okay. It's a weird thing to do.
They stole one small piece of
Where did they slowly see it from?
the science lab. Oh, one of it, in science.
That's so dangerous and so naughty and
They took one sodium. They went to Taman Chan and made a video and said we're gonna toss you in Taman Chan. They just actually toss
so bad. They were arrested. My goodness.
tossing. Okay. They got taken off.
Catholic high school. They should. It's so dangerous. They would have killed all the fishes, and then it's environmental. They should have gotten arrested as well. It's considered pollution. It's very bad pollution. The poor fish. So naughty. Okay. Anyway. All right. So group 1 is the vertical column on the far left of the periodic table. Okay, so it's lithium, sodium, potassium at school, but rubidium and cesium are considered to be too reactive to use in the classroom. Francium is radioactive and very rare. There are only few grams of it in the whole earth crust. Okay, can? So this is group 1. So we're going to talk about them. So it's this one. That's why only researchers can find it. Lah. Okay, so iron and other transition metals have high melting point, but they have low melting point. Compared to other metals, their melting point is lower. So common metals are like what? Iron, cobalt, nickel, copper, silver, gold, platinum. These are normal metals. They got high melting point. But group 1, alkali metals have lower melting point. Group 1 is hard. Group 1 is soft. Transition metals are hard. They're very soft and can be cut with a knife. You can take iron and cut with a knife. Go and cut with a knife. No. They have low density. They will float on water. As compared to iron will sink in water. They react with non-metals to form white ionic compound. Okay, all the transition metals form colored compounds. They react quickly with water and they produce an alkaline solution. Because they produce an alkaline solution, that's why they are called alkaline metal. Get it? Okay, so as you go down the group, the size becomes bigger or smaller? Bigger. First one is 2-1, 281, 2881, 281881, 281881, 281832, So it becomes bigger and bigger and bigger and bigger. So the atomic size becomes bigger, and the most important thing that you will learn today, it becomes more reactive as you go down the group. Okay, so the most reactive between all of this is francium. But if you only have lithium, sodium, potassium, the most reactive is potassium. The least reactive is lithium. Okay, so when you go down, melting point and boiling point decrease, atoms get bigger. Okay, density increases, hardness decreases. Okay,
Salt was fancy.
very soft. All right. And it becomes more reactive. That's the most important. Okay, so we're going to look at the video of this.
Yeah.
Okay,
Yes.
so what happens when you put them in water? Yeah. Okay. The reaction with water is very exothermic. Very exothermic means releases heat. Okay. A lump of lithium sodium potassium is placed in cold water. No need to put hot water, it will explode. It will start fizzing because it releases hydrogen gas, and an alkali metal is formed. Okay, can? So you look at this equation. Sodium, wait lah. Sodium plus water, sodium hydroxide, and hydrogen. Sodium hydroxide is alkali. Okay, I want you to write an equation of potassium and water and lithium and water. Do it now.
One.
Potassium and water and lithium and water. This is sodium right next to this lah. Anywhere lah. Of this equation I'm showing you is sodium and water. I want you to write for me potassium and water and lithium and water. Yes.
Listen. One. One.
I'm going to tell you. S is solid. Okay. So what you do is you take a piece of sodium or lithium or potassium. These are metals. Metals are still solid. That's why S. Water is a liquid. Okay, water is a liquid. When it dissolves, it becomes an aqueous solution. Aqueous solution is something in water. Water is liquid. Salt in water is salt water is aqueous. Okay, can I answer? So if it's lithium, it's lithium hydroxide. If it's potassium, it's potassium hydroxide. So these are aqueous. And hydrogen is obviously a gas. Okay, can? All right, so balance the equation, 2, 2. Yeah. All right, so I'm going to show you the video now. Okay, so when you go down, it becomes more and more reactive. And what happens is it becomes more and more reactive and then it spins faster and faster in the water. And finally, potassium, it will catch fire because it's so hot, so exothermic that the hydrogen burns. Okay, can? All right, we're going to find out why in a while. Another one is if you take sodium and just burn it, just burn the sodium, you react with the oxygen in the air to form sodium oxide. Do you know why sodium oxide is Na2O? Because Na is positive 1, O is 2 negative. Okay, so if sodium reacts this way, potassium, lithium all react the same way. Lah. Okay, finally, if you take this oxide, you dissolve in water, it will still form an alkali because it's very, very soluble in water. Okay, can? All right, all the group 1 can react with group 7 or 17 to form a salt. Okay, so can you try and write equation for me for the reaction of, so this is sodium and chlorine. Okay, can you try and write for me potassium plus iodine, word equation and chemical equation, and lithium plus bromine. Okay, no,
Why? Why?
for what? No, no, cannot, you can't do that.
Having and the
Potassium iodide. I1 negative. Iodine is I2. Don't confuse the two. All right, so potassium plus iodine. Potassium iodide is Ki. Now, please don't confuse iodine with iodide. Okay, and then balance the equation. 2, 2. All right, lithium plus bromine become lithium bromide. Okay, okay. Do you get it? All right, so remember, group 1 is very, very reactive. Okay, now we're going to find out why. Okay, ready? Can I? Okay, so first of all, let's just talk about the first three atoms. Lithium, sodium, potassium. Okay, so 281 and 2881. In order to form a full outer shell, what will they do? Will they gain electron or throw away electron? Think again. Okay, so from 2, 1, in order to form a full outer shell, it will throw away that one electron to become just 2, positive ion. Okay, 281 becomes 28. 2881 becomes 288. Okay, so all of them will throw. So it will throw the electron. Now, first of all, before I continue, what is the charge of an electron? Every single electron has a charge of -1. Who is in the nucleus of an atom? Proton and neutron. Neutron is neutral, 0. What is the charge of a proton? Okay, so every single nucleus is positively or negatively charged. Nucleus, positively charged. Correct, not? Okay, so sodium is 281, means it has 11 electrons. How many protons will it have? 11, very good. 11 protons. So that means, what is the charge of the nucleus? Positive 11. So this one will be positive 9, sorry. This one is positive 11. I clicked the wrong one. This one is positive 11. This one will be positive 3 lah. This one positive 19. But basically all positive. Okay, now we don't look at the positive how much. We just think positive or negative. So now we know everybody, the nucleus is positive. So the positive nucleus is holding on to the electrons. What is the charge that is holding on to the electrons? Electrostatic forces of attraction. Electrostatic forces of attraction is holding on from the electron to the nucleus. Okay, Ken? Now, in order for the electron to run away, the electron must be able to overcome the electrostatic force of attraction and then run away. Correct? Okay, so who finds it easiest to run? The nearest or the furthest away? The furthest away. Because the further it is, the weaker the attractive force. The positive is like, oh, I cannot catch you, I cannot catch you. So as it gets bigger and bigger and bigger, the atomic radius becomes bigger and bigger and bigger and bigger. So its attractive forces is weaker and weaker and weaker and weaker. And so it's easier to release. The easier it is to release, the more reactive. So that's why going down group 1 is very reactive. Okay, it loses an electron to form a noble gas or just full outer shell. Okay, as you go down, the atomic radius gets bigger. So the outer shell is further and further from the nucleus, and it's also shielded by extra negative electrons. So the valence electron is less and less strongly held. So it's easily lost. Can you understand? So this is how you explain why it is more and more reactive going down to 1. Can you understand? Okay, so now we're going to talk about group 17. Yeah, so group 17 is halogen. The reason is they are called halogen is not because they like to say hello, it's because halogen means salt formers, to form salt. Okay, in the periodic table, they are FClBri, but in natural state, they exist as F2Cl2, Br2, I2, AT2. This is naturally occurring because the atom has 7 valence electron. Okay, the reason why you're going to learn in the next chapter, but I just tell you briefly now. Fluorine has 7 valence electron. In order to achieve full outer shell, how many more does it need? 1 more. Another fluorine also has 7. It also needs 1 more. So they talk to each other, you give me 1 lah. No, you give me 1. No, you give me 1. No, you give me 1. So they decide, okay, like this, that we move closer together. So this one has 1 and this one has 1. So they all got very smart. So this one has 7. 1, 2, 3, 4, 5, 6, 7. And then the 8 one comes from here, but it thinks it belongs to itself. Not very smart. Lah. And then this one also says, it also got 8 now. 1, 2, 3, 4, 5, 6, 7 actually belongs to itself. And then the 8 one comes from the other side. So both of them think they cheated each other. So in natural conditions, they exist as F2, Cl2. That's the reason why. Okay, they don't exist as molecules. So this is called a covalent bond. They don't exist as atoms, they exist as molecules. So it's called a covalent bond. So when we talk about attractive forces, we're not talking about this bond. We are talking about this fluorine and this fluorine, this attractive forces. So this is called an intermolecular forces of attraction. You will learn again in the next chapter. Okay. Now, as you go down the group from fluorine to chlorine to bromine to iodine, the size becomes bigger or smaller? Bigger. So because the size becomes bigger, the attractive forces between the molecules become stronger or weaker. Stronger. The size is bigger. I want you to think of it this way. This is the sun, this is the earth, and this is the moon. The attractive forces between earth and sun and earth and moon, which one is stronger? Earth and sun, of course. Why? Because sun is so much bigger. The bigger it is, the larger the attractive forces. Get it? Makes sense or not? Okay. So of course, Earth and Moon also got attractive forces, but the Sun and the Earth is stronger. This is bigger. Okay. So the bigger it is, the stronger the attractive forces. So that's why when it's stronger attractive forces, the boiling point and melting point is higher or lower. Stronger attractive forces, higher or lower, melting point, boiling point, higher. So from up, it goes from gas, liquid, solid, solid. Okay, can. Now, one thing you must remember, when I talk about gas, liquid, solid, all this, right? We are talking about its natural state. Natural state. The iodine that you use in the school to test for starch, that is iodine solution. That is 黄药水. You know when you're injured, that one? The lab one. That's iodine. Fluorine is the one in toothpaste.
This one is probably
This one is natural. Okay. This one is natural state. The iodine solution, the 黄药水 is we take the iodine, mix in water. So it's not the same. So this one, they're talking about natural state. So as you go down, it goes from pale yellow, green, reddish brown, purplish black, and black solid. So the darker, darker. And then the size also because gas, liquid, solid, solid.
I'm
What did I just say? That one is 黄药水. That one is dissolved in. This one is in its a natural state before you dissolve the water. Okay? That one is called iodine solution. This is talking about iodine. This is a very common question that students may get mixed up. Like for example, your fluorine that you brush your teeth, you brush your teeth, your toothpaste is gas. No, it's changed into a fluoride salt. Get it? Can you understand? Yeah. Okay. Now, okay. They all have 7 valence electron. 7. In order to get full outer shell, do they want to gain electron or throw electron? Gain. They want to gain one to become negative. So this one is called halogen. This one is called halide ion. So it's fluorine fluoride. Okay, they want to gain electron. So just now in group 1, going down more reactive because they want to throw. But now going down is less reactive because they want to throw or catch. Catch. So the bigger it is, the harder to catch. So it's less reactive going down the group. It's terbalik from group 1 because the size of the atom becomes bigger and bigger. Its attractive forces between nucleus and valence electron is weaker instead of stronger. Okay, can you understand? Get it? Okay, so when a halogen atom reacts, it gains an electron to form a negative charge ion. It has a stable electron. Okay, as you get down, the atomic radius becomes bigger. The outer electrons are further and further from the nucleus and are also shielded. Therefore, it is less and less strongly attracted. Okay, so it means to attract an 8 outer electron is more and more difficult as you go down the group. So it becomes less reactive. So go down group 1, more reactive. Go down group 17, less reactive. And this is the reason why. Can you understand? Okay. So the melting point, boiling point also increases because the intermolecular attractive forces between molecules are, the one I showed you just now, it's known as van der Waals forces of attraction. As you go down, it becomes stronger and stronger. They are non-metals, so they are poor conductor of heat and electricity. Okay, and the size of the atom gets bigger. Okay. When they become negative, they're called halide ions. Can you understand? Okay. Yeah, yeah. Okay. All right. Hydrogen can react with halogen to form hydrogen chloride. This one looks very familiar, right? Now it's a gas. Now it's a gas. You take this gas, dissolve in water, it becomes hydrochloric acid. So when hydrogen and halogen react, they form a very acidic gas. Acidic gas is acidic because it dissolves in water to become acid. Is it? So isn't group 1 exactly terbalik from group 17? Group 1, metal. Group 17, non-metal. Group 1, release electron. Group 17, gain electron. Group 1, atom. Group 17, molecule. Group 1, going down, more reactive. Group 17, going down, less reactive. Group 1, dissolve in water to become alkali. Group 17, react with hydrogen and then dissolve in water, become acid. Can see? Okay. So the hydrogen halides dissolve water to form very strong acids. Okay, okay, can you do this exercise really quick? It's just it's just 8 questions here. Just a few questions. Answer here. Just to see whether you understand. If you understand, we'll go back to counting. Okay. Wait a minute. We go along as we go. Compared to most other metals, what properties do group 1 elements have? Ah, group 1. Low melting point and low density. When sodium hydroxide dissolves in water, an alkaline solution is formed, okay?
I think I got messed up with it.
What gas is produced when lithium reacts with water? Hydrogen. Which alkaline metal is the most reactive? Potassium. Why is sodium stored under oil? Okay, the oil is called paraffin oil, okay, to away from air. So
Softest condition.
which alkaline metal is the softest out of potassium, potassium? Okay, so if you look back at the yeah, so you can see here the uh where is that? There, the hardness decreases down the group. Okay, so potassium. Okay, how many chlorine atoms? Two. Which properties best show the described halogen? Poor conductors of heat and electricity. Most reactive, fluorine. Why do hydrogen halides form when they dissolve water? Acidic solution. When halogen reacts with other elements, what sort of compound do they form? Okay, so halogen is a non-metal. So a non-metal will react with a metal to form ionic and molecular compound with a non-metal. This one you will learn in the next chapter. Okay. Which of the statement below best describes the properties of halogen as you go down? The element becomes less reactive and higher melting point. Okay. Next week we have class. The following week only is fire break. Okay? Yeah. All right. Okay, I want you to do this question first. Just always like war zone like that. Okay. Now let's try this question. Sekejap ah. And there's one question. Okay.
Where is it?
The front of the question. Okay. Question 8. Just now we did some right. Question 8. Okay. Read the question. First, I want you to try and write a balanced equation first. Okay. So this one 0.3 mole. Let's find out how much mass of this first. So if this one is 0.3, magnesium oxide is how many moles? Same or half? 2 to 1. What? Okay. MgO is 40, right? How much is it?
What's this?
Okay. This one is how much? 155. 6. Yeah, correct. Okay, so pills. Each pill is 3 grams. So it's just 6 divided by 3, you get 2 pills. Okay, now, if your calculation is different, did you get this?
Yeah.
No, you still get 2. Can, but you have to write down what you're doing. Each pill is 3. They're asking you how many pills to take. Why?
Fire.
No, I'm okay. I still have.
We do the next one.
Yeah. Okay, wait. The next one. Yeah, not decided done already. Yeah, number 10. Okay, calculate percentage purity. I'll explain to you what's percentage purity. You all do the mass first. Okay. First you do the equation first. Decomposes means only one product. You don't add, sorry, decomposes means only one reactant. You don't need to add anything. That means it's just the calcium carbonate arrow. Okay, no, you calculate, you do the equation first. All right. Have you done the equation? It was small. Okay, wait. Calcium. Okay, look. Is your equation like this? Okay, so this like this. Okay.
Yeah.
8 grams of impure. Impure means got other stuff, not just the calcium carbonate. But when you heat it up, so this one is impure. When you heat it up, 2.8 grams of calcium oxide. Okay, so 2.8 grams of calcium oxide how much calcium carbonate did it come from? That means in this 8 grams, how many is calcium carbonate? Do you understand? Okay. I got a 1 kg box of oranges. But in that 1 kg box, is all of them oranges? No, maybe got in the middle, got paper, or whatever. So what I say is every one orange, when I squeeze out, got 500 ml. So if I squeeze out 8 ml of orange juice, how many oranges were there in the crate? So you're counting the balik, understand? So now what you do is you find out the moles of calcium oxide first. Do that first. No need, just calcium oxide. Hmm?
0.05.
Okay, so 2.8 over 56, 0.0. Okay. So if this is 0.05 mole, this is supposed to be 0.05 mole. Okay, so the mass of calcium carbonate is supposed to be 0.05 times 100. Molar mass of calcium carbonate is 100. So how much is this? 5 grams. So in actuality, there is actually only 5 grams of calcium carbonate. 5 grams of calcium carbonate is pure. How many of it was the impure sample? 8 grams. Get it? So the percentage purity, 5 grams out of 8 grams. 62.5%. Make sense? Only 62.5% of this is pure. The rest is impure. Can I understand?
Okay.
Okay? Can? All right. Okay, this one all you go back and do. 11, 12, 13, you do as homework. 14 also do as homework. Okay, this one I taught you already. Okay, there's one question here that's very important. I want you to try and do here. Okay. Question 12. I don't know why it got accidentally pushed down here. Yeah, question 12. Yeah. Okay, try and write the equation first. Try the equation first.
One so solid sweetness.
What's given? Do.
Is it?
N3.
It's given.
It's given. It's given in the question. Sorry, this not the one I taught you. Okay. Sodium. Sodium azide is a what? Solid. It decomposes rapidly in an accident to form sodium and nitrogen. And sodium is a solid. Nitrogen is a, okay, how to balance this equation? This one you must use 3, 2, 2. Get it? Okay. Now, is your equation correct? You answer now? Okay. Do question B and C. That's it. Just do B and C. Then we will, I think then we are done. All right. So first, we find the amount of moles of nitrogen. 72 over 24. How many moles is that? So if this is 3 mole, this is 2 mole. Right or not? So the mass of sodium azide is 2 times. Huh? No, it's 3 to 2.
But
So if it's 3 to 2, it's just 3 to 2 lah. So it's 2 times what sodium azide? 23 plus 14 times 3 is how much?
answer is so big.
130, and then you get 260 gram. Correct? 130 is the final answer.
Wow.
Say properly lah. Ayo.
I thought it's like nitrogen is in nitrogen. Like
No, nitrogen is like 14 times 3 plus 23, 65, 130 grams.
1,000. It is about 1,000.
Okay. What is the empirical formula for compound A? So hydrogen and nitrogen, 2.33 divided by 1, 97.7. Wait lah, I'm showing the OFG 22.33, and then this is 97.7 divided by 14. So you get 6.9. 6.7 lah, huh? So you take H and 2.33 divide 2.33, you get 1. And then 7 divide 2.33, you get 3. So it's NH3. So when ammonia lah,
I thought it's H.
it's ammonia. So sodium azide reacts with dilute hydrochloric acid to give sodium chloride and compound A and H3.
Wait, what? Wait.
It's here in the question.
I thought nitrogen is.
What?
I thought nitrogen is.
And oh,
Yeah.
sorry. H and 3. Yeah. I was looking opposite. H and 3, which is a really weird thing. But it's correct. Wo. Okay lah. H and 3. Some weird thing lah. Okay. So, is it balanced? Balanced already lah. Balanced already lah. Ta-da! Okay. Wait lah. Okay, go home and finish this homework. Not that many already. Go home and finish the That four question. And then previously the old one done already, is it?